These houses that are passive solar have a tremendous amount of light in them in the winter time. And this is all good for your health. The primary concept for designing a house is the health of the occupant. So it's a health related thing more than it's an energy related thing.
Hey everyone, welcome to another episode of Vital Roots, where it's our mission to share unconventional solutions to the biggest challenges facing our health and environment. Today we have the opportunity to tour two homes designed by John Spears of the Sustainable Design Group. So these homes built in Maryland are not only energy independent, but they're also designed to create the healthiest environment possible for the occupants. So excited to learn more, so let's go check them out.
This is south. And so if you look here, you'll be able to see all the windows are facing the south to heat the house just like the other house.
Mm-hmm.
And then the walls are concrete, insulated on the outside with the foam. And the overhang, if you'll notice how the sun is coming into the windows now, in the summertime, that overhang will shade those windows 100%.
Oh yeah, because the arc of the sun is
Right,
higher.
because
Yeah.
the sun will be higher in the sky. And then the solar panels go on that roof. That's why that roof is a shed roof. That roof will be completely covered in solar panels, and the batteries and everything will go in the garage.
This type of roof basically allows putting more area for the solar panels.
That's right. This
Okay.
maximizes it.
I've read a lot about passive solar, and then I've also seen this subculture of green builders who kind of are very dismissive about passive solar for some reason or another, as if it can't be of a significant benefit. I'm struggling to understand like why somebody would have that sort of mindset, because like they can apply those same principles.
And this has been an issue as long as we've been talking about passive solar and just insulate the heck out of the building. When I first started out, there were two camps. There was the passive solar people, that were building houses mostly in the Southwest and powering them almost completely by the sun coming through the windows. And then there were the people that were called super insulation. In other words, you build your walls as thick as possible. You have like 5 panes of glass and very little glass, and you just make the house super insulated. They both work if all you care about is reducing the energy bill. They can both work. It's harder to do passive solar in our Northeast climate than it is in Arizona. And I learned that lesson very early on when I learned about passive solar in New Mexico and then came here and tried to figure it out when we have half the sun that they have down there. So it was a little more of a challenge, but doable, absolutely doable. But it's not about just saving energy. It's about the quality of the living space that you're giving the people. These houses that are passive solar have a tremendous amount of light in them in the winter time when many people are suffering from winter
the seasonal affective disorder.
Yeah. It's because they're not getting enough sunlight. In a passive solar house, all the sunlight's coming in the wintertime, right? And you have very bright sunny rooms. You can put lots of plants in them. And this is all good for your health because, like I said, the primary concept for designing a house is the health of the occupants. So it's a health related thing more than it's an energy related thing. But a passive solar house can be just as energy efficient as a super insulated house.
Yeah, that's a good point. It's another common sense thing, but I hadn't really thought of the passive solar design as a health promoting sort of design feature. But we need the sun. Passive solar design is a practice that acknowledges that we have this free, unlimited energy source called the sun that should be at the core of every design decision when it comes to building homes. Basically, what it implies is that we can heat our homes simply with the use of the sun instead of relying primarily on external energy inputs. So in the northern hemisphere, when the sun is going to be lower on the horizon, that means we're not going to get the sun coming straight from overhead. It's going to be shooting into the home from the south side. And now that's why this home has a lot of south-facing glass that allows that low winter sun to enter the home and to actually heat it up. And when that light interacts with thermal mass materials, that allows the home an even greater ability to warm itself and to stabilize its temperature. Now, you may be wondering, why isn't this an issue during the summertime? Are we going to let in too much heat during the summer? Well, that's not the case because in the summertime, the arc of the sun is going to be much higher. So that means we're going to get more of those rays coming down from overhead straight onto the roof. And therefore, all these windows and this south-facing wall is actually going to be shaded by this overhang during those summer months when the sun is much higher. So ultimately, we all need the sun to be healthy. So passive solar design is just a way to make sure that we are designing with nature instead of in opposition to it. And energy efficiency is just a beneficial side effect of designing in that way. So given that this site has a lot more elevation changes, how does that play into the design process?
I didn't want to clear cut the land and, just regrade everything. So the house is actually stuck into the grade on the back side. So the soil comes up to almost the windows on the back side of the house.
Yeah.
And on the garage, it comes up even higher to more about 5 feet up the wall. And so this wall is partially below grade. But that allows, the slope of the land goes this way, that allows the south side to be completely at grade and with the big windows and let all the sun in.
Oh yeah.
And it also provides a bit of a buffer for the energy that this is sort of below grade.
Okay. Is this home on the grid, or is this going to be?
It's on the grid, but it has solar and batteries enough to power it indefinitely.
Okay.
So I call it grid independent. So we got the grid, got all the power you ever want from the grid, but if the grid ever went down, or when it goes down in a hurricane or something, you're fine. The batteries will carry everything.
Okay.
It's got a really big battery system in it, so the heating and air conditioning and everything will run as normal.
The batteries, do they tend to be the limiting factor when it comes to keeping the energy going, or is it getting enough solar for a given size home?
Yeah, so it's a combination of one, how much energy you need, so, which is a function of the weather. So if it's 6 degrees outside, you're going to need a lot more energy than if it's 70 degrees outside.
Yeah.
Right? Then how many days of autonomy do you need? In other words, how long does all that stuff have to run?
Yeah.
And then how much solar do you have to recharge the batteries? So it's a very complex, dynamic design that factors in all that stuff. And it's still a judgment call, because at the end, you don't know the weather, and the weather drives everything. And, do you have an outage during the week of 6-degree weather and cloudy every day? Do you design for that?
Oh yeah.
Yeah, right. The system would be ginormous if you did that. Or do you design for more average, typical days? We take what's called typical meteorological data, which is collected over 20 or 30 years, and then they give you a typical year, hourly data for a typical year, and we design the house to that. But also the owner has the option to cut back if the weather's really bad and they need to conserve batteries. They can always turn down the thermostat, turn off unneeded appliances, that kind of stuff. This house, you could turn off the heat and it'll stay comfortable for days and days without power at all on the HVAC, and that's the biggest energy consumer.
Yeah.
So,
I mean, compared to a house that's not designed in a way that retains the heat,
right.
then, I mean, within the same day, you'll be freezing.
Oh yeah, a typical house will start getting cold within hours of turning off the power. And overnight, it'll be very close to outside temperatures, and things will start freezing if it's really cold outside. This house could take a week to get to that, to get to be an uncomfortable temperature once the power goes out. R value is a static number. So they put the insulation in a box, heat one side, cool the other side, which creates the temperature differential, and measure the R value. And it's pretty much the same, just as long as you have the same temperature differential.
Yeah.
A thermal mass is something that has the capacity to hold heat, and that capacity it's called capacitance. And so that is a number. Concrete has a high thermal capacitance. Water has a significantly higher thermal capacitance, and if I could build the building out of water, it would be even more thermal mass. And in some cases, they actually put drums of water in greenhouses and stuff for the thermal mass quality of the water. But concrete's a little easier to work with. The other component has to do with a time constant, how long it takes for the heat to go in and how long it takes for the heat to come back out. Concrete ends up being the perfect material, so, because what that means is for the 8 hours during the day that the sun is heating the building up and the heat is going into the wall, and then the sun goes down and now you want that heat to come back out of the wall, the heat actually never gets to the insulation. It's in the middle of the wall, so that heat bar inside the wall is moving in and out to maintain the building at the same temperature.
You technically wouldn't need as much insulation to get if you have more mass on the inside.
Exactly. Yeah, you can use less insulation. Now, I'm still using the code required amount of insulation because I like more is better.
Yeah.
And it avoids me having to explain that to a code inspector who says you don't have enough insulation in your house to code.
Yeah. Okay, that explanation makes a lot of sense now.
Now, if you build out a wood frame, there's no capacitance to hold heat. So if the temperature outside gets cold, as soon as the heat is turned off, the building is going to get cold very, very quickly.
So if somebody is moving into a stick frame building and they're wanting to make a renovation in order to improve the energy handling, what could they look to do to make the biggest impact?
So I think the first thing is you're going to want to look at the attic and make sure you have lots of insulation in your attic, because that's the biggest area that covers the whole house, and insulating that is really most important. However, the single biggest driver for the heating is air infiltration. So you want to get what's called a blower door test, and you get people to measure the leakage of the house and air seal the house as much as possible. You want to make an airtight house. You then have to make sure you've got bath fans or a ventilator to keep the house ventilated, which is a very simple thing to do. So you don't sacrifice indoor air quality for the air tightness.
Okay.
And sometimes we combine that, insulating the attic, like we're doing here. Instead of blowing insulation in the bottom of the trusses there, we're using a eco-friendly spray foam on the roof, all the way around the roof. So the attic will be inside the conditioned envelope.
Oh, okay.
But what that does is it air seals the whole roof of the house in a way that the fluffy fiberglass you put in the attic doesn't.
Yeah.
Air goes right through it. Because when you put in fiberglass, you have to ventilate the attic. So you have to have openings in the attic to let the air out. And all that air is coming from all the recessed lights in the house and the electrical outlets and all that is leaking air out of the house and going out the attic. And it almost has to be to prevent condensation in the attic. But if you spray foam the whole thing, you have an airtight building and no issues with the condensation of the roof. Over here is the laundry room. Then we have stairs to the basement, full basement. This is a home office. Plus this building has a geothermal heat pump, which uses the ground energy for the heating and air conditioning. And it has all radiant floors in the basement and at this level. And then it has the energy recovery ventilation system that pulls the stale air from the bathroom and exhausts it outside. And then that exhaust air preconditions the fresh air that comes in and then is redistributed throughout the house in the duct system. So you have a continuous fresh air system with a minimum loss of energy in the process. So for sustainability, I look at sort of a human-centric design. What's important for the humans? Well, we want to make sure they're not getting sick, so we have a healthy house. But there's a few other things too, like, you know, with the forest fires in California or brush fires, we don't want it to burn down if he had a brush fire around here. So the house is completely non-combustible with stone and concrete exterior, metal roof, and so on. So they can withstand a fire. Two, The solar system will provide full heating, air conditioning, cooking, water, flushing toilets. All that stuff will run during a disaster. For instance, if the power gets knocked out for a week, they don't care. Everything works. It's survivable.
Yeah.
I know houses in the rich parts of Potomac, most of them, if the power goes out, they got to move to a motel, a $5 million house. This one will coast whatever storms and outages thrown at it. And that's the safety part, right?
Yeah.
Security. This has got concrete walls on two sides. The other two sides will be basically ballistic.
Okay.
And it'll be like a vault door.
Okay, yeah, like a safe room.
It's a safe room and valuables, and that's why there's no windows. So these walls are 6 inches of poured concrete with 4 inches of foam on the outside. And then the inside, we furred them out so we can put drywall on there.
I guess concrete has somewhat of a bad reputation when it comes to people that are concerned about the carbon footprint. So what makes concrete a good building material for a home that is meant to be sustainable?
Right. Everything has a carbon footprint. Even the lumber has a carbon footprint because it's probably all harvested from a forest in Canada and shipped all over the place. And, so everything has a carbon footprint. The nice thing about concrete is it reduces the energy requirement of the building for heating and air conditioning significantly. And over the life of the building, that is a much bigger carbon footprint than the manufacturing of the concrete itself. So it offsets itself in energy savings. The other thing we do is we try to use a green concrete. Basically, it replaces some of the Portland cement with fly ash, which is a byproduct. It's the residue of a coal-fired power plant. So anytime you got coal-fired boilers, you get lots of fly ash. And they mix that in as a substitute for some of the Portland cement to reduce the Portland, which then reduces the carbon. There are other additives that can be used that are being experimented with, but that's a pretty common one that you can ask for with your concrete.
Just out of curiosity, have you used any building materials that include biochar in them, or do you know of anybody like experimenting with that sort of thing?
No.
Okay.
No. I've also never built with hemp.
Okay.
I haven't tried that yet. I haven't seen the benefit case for it yet.
Yeah.
One client asked for it, and I said, well, what do you want to use it for? Insulation. It's a terrible insulator. I can get other things that are just as organic that insulate better and are cheaper. Things like that. It's not structural, so you still got to build your structure. The most innovative stuff I've used is compressed earth bricks, and I've done a number of houses around here and in Virginia. And basically, you take the soil from the site, and you take the clay and the sand and mix it with a little bit of lime, and put it in a mold and compress it with a hydraulic ram and make bricks. And then we build the house out of that. And then everything else about the house is like this one's built. Instead of having concrete walls, it has earth brick walls, and we insulate that on the outside and then plaster it on the inside. And that has an extremely low carbon footprint. It's mostly just running the compressor that runs the press. That's it.
So for somebody who's looking to build this type of a home, what questions should they be asking an architect or a home builder to make sure that they're aligned with what their goals are?
Well, you want to ask them a couple of things. One, what is their approach to the health of the house and the health of the occupants? What are they doing to make sure that the health of the occupants is number one in the design? And that includes technologies that you could ask about, like an energy recovery ventilator. Like the client for this house was screening builders by saying, what brand ERV you use? And most of them just looked at them with blank look, they don't know what you're talking about. But that's a good sort of qualifying question. The other one is, I'm very keen on passive solar design because it means you've connected the house to the land and the sun and the natural flows of energy in the space. Ask the architect their experience with passive solar. And if they blow you off, they probably are not going to be connecting the house to the earth like it needs to be,
Mm-hmm.
you know. But if they know about passive solar and indoor air quality and they'll talk your ear off about it, that sounds like a good person to me.
Okay. Thanks again to John Spears of the Sustainable Design Group for teaching us about passive solar design and building energy independent homes. We definitely learned a lot, and I think my main takeaway was realizing that passive solar design is primarily for the health of the occupants, and the energy efficiency part is really just a beneficial side effect. Because like as John was saying, if you design for health, then everything else tends to fall into place.
That's true. It was actually really refreshing him emphasizing on that because even as a health conscious person myself, I didn't really make that connection before,
Mm-hmm.
even though I was aware of what passive solar design was. And I feel like in the future, when I go into a space that I'm going to be spending a lot of time with, I will be considering
The health
the
benefits of
health
it.
benefits of it instead
Yeah.
of like what does the space look like and the functionality, which that to me from now on it would be more of a secondary thing.
Yeah, yeah. Because it's definitely we are kind of taught to emphasize those surface aesthetics when really the first thought should be, is this a healthy environment for people to be in?
Mm-hmm.
You know, we think about it with our pets and, even livestock, things like that, but we don't really prioritize it when it comes to humans. We think more so about resale value and things of that nature, but when it comes to our own health,
Yeah.
what's a better return than investing in your health?
Correct. And I think the spaces that we spend the most time in should be more about that versus like as far as like a place to just leisure or kind of just like
Lounge around.
lounge around.
Yeah.
Yeah.
So we actually have another episode with John
Mhm.
coming up where we delve a little bit more into his design philosophy and how he got started in his career. So that's another really interesting one.
Yeah. And we get to see, you guys get to see a completed space. So
Mm-hmm.
that's a good aspect.
Yeah, and we get to talk to the owner about
Mm-hmm.
how it's been living completely off grid. So keep an eye out for that one. And yeah, so thanks for watching. Leave any questions or comments, and we'll see you next time.